Okay, so where we last left off, we kind of looked at how did we start getting more multicellular organisms, but that was it. So we still have a lot of history to cover. Specifically, though, we kind of care. How did we come about? Does anyone know what our common ancestor is? Primates. Yeah. So we're looking at primates, and this is I think it's 16, if I recall correctly. So we're looking at primates here. Now, we are eventually going to get to the theory of evolution. We're not there yet. We'll deal with it later. But we are looking at primates, and we're looking at common ancestors. But specifically, we are not only now looking at the biological measures. We're not looking at the genes. Now we're also looking at behaviors as well. So here we go. So we have humans, apes, monkeys, and lemurs. All of those belong to primates. Most people can get these three. The lemurs tends to be one that most people forget about. So what does it mean to be a primate? We'll learn how to classify stuff later, but primates, sorry, no, we haven't learned how to classify, yeah. So primates have a couple things. We have really high levels of manual dexterity. What the heck does that mean? Manual dexterity. It means we have good endurance. We have really good endurance. We have pretty good eyesight, very complex brains, and we exhibit behaviors, specifically very social ones as well. But the thing that draws primates apart from most other organisms on Earth is very specifically the brain. There are other very smart animals out there: octopuses, dolphins, dogs, very intelligent, of course, but humans are for sure definitely the most intelligent. So it's our complex brain that really separates us apart. So manual dexterity. Again, that means some physical endurance, but it also means one other thing. Hands. We have 5 digits on each foot and each hand. And specifically, we have an opposable first digit that can be brought across the palm of the foot and touch other digits. What the heck does that mean? Our thumbs. So thumbs and our ability to work very precisely with our hands, also a very key feature of primates. So if we're looking at our senses here, we rely more on vision than our other senses. Vision's our most used sense. We have what's called binocular vision. We have overlapping fields of vision, right? If you have your left eye, you have your right eye. If you kind of close them, like if you just alternate between them, you're going to see that you can still see most of the same stuff. But if you close your left eye, you might not see that dream banner, for example. If you close your left eye, you might not see, or sorry, if you close your right eye, you might not see that. So you don't have complete vision, but together you've expanded your vision, but 2, you now have better depth perception. If you've ever tried to play a sport with like one eye open, you're not going to do well. It messes with your senses. So 2 eyes gives you depth perception, which makes it easier to, of course, judge distance, movement, etc. Most primates are active during the day. We've all heard of what nocturnal is. We know what nocturnal is. Nocturnal is active at night. Diurnal is active during the day, is the official term. So we are mostly diurnal. We very much rely on our sense of sight, and we also have really good color vision. Some primates are nocturnal, but most are diurnal. So how do we move? It kind of depends. Most primates, primates do have flexible bodies. We have limber shoulders and hips. We mostly rely on our legs to kind of get around. Now, here's one of the features that makes humans more distinct from other primates. We walk on our feet, right? Only on our feet. Other primates can walk on their feet, do walk on their feet, but they also walk on all four limbs. So this is something that makes humans specifically a little bit more unique. And next, of course, we have our big fat brains. We have very large brains for our body size. For context here, if you think about a T-Rex, think about how big a T-Rex is. We've all seen them in movies. Their brain is the size of a golf ball. Our brain is, I don't know exactly how much bigger than that, but a lot bigger than that, right? So we have very large brains for a relatively small body size, comparatively speaking. So with this, so we have less brain area devoted to smell and more division, and we've talked about that. But one thing that humans have, along with a couple other animals, is we have really good problem-solving skills. Other animals have that. We also have very complex social behaviors. Again, other animals also have that. Not just primates. You think about wolves, complex social behaviors. If you think about crows, they're very good at problem solving, for example. Octopuses, dogs, etc. So not uniquely primates, but a common feature of primates, of course. So how do primates make babies? How do humans make babies? I'm not just saying, well, you have sex, but think about it, like with the baby, we usually only have one at a time. You can have more, but most commonly it's just one kid. Our pregnancies are very long. And this is, again, not specific to primates, but a feature of them all. We have a long period of maternal dependency. What does that mean? If I go and have a baby right now, that kid needs me, absolutely needs me, right? Needs me to survive. If a zebra in the wild has a child, that zebra will literally be walking in 1 minute. So less dependent on specifically the mother, but the parents. Obviously they are, if you just have a zebra in the wild, have a baby and then mom runs away, the zebra is not going to survive, but it doesn't need a lot of time to eventually become self-sustaining. It'll be fine after a while. So humans, our newborns, take years. And I want us to step away from our modern world. Think about 100,000 years ago. We barely just got on fire. We can barely even I don't even know if we could speak back then with language. I don't think we had a language back then. But so we were carrying what in all terms is the kind of a leech. We carried a leech with us for years, right? They can't fend for themselves. We have to take care of them. They could put us in danger, crying at night when there's predators around, taking our energy and time. So it's a very unique thing of primates to have something with that long of maternal dependency. Other animals have that, but not quite to the same duration. We also have a pretty low reproductive rate. Specifically, well, not we, but all primates do. So we take a low reproductive rate. There's not a lot of kids. That tends to happen. You think about rabbits, you think about cats, think about dogs. They can have dozens, hundreds of children throughout their lifetime. You think about humans and primates, maybe 10. And how many of them survive? If we think, again, go back 1,000 years ago, how many survived? 150 years ago, it was a coin flip if a kid's going to survive to be 5 years old. Think about 1,000 years ago. So there's a lot of primates. In fact, I think every primate actually is endangered, except for some lemurs. But otherwise, every other primate is for sure endangered. So when most people think primates, what do they think? Monkey, gorilla, chimpanzee, a baboon. It's actually quite diverse. There's over 200 species. within it. So most are tree dwelling. But we actually separate these primates a little bit. Again, we'll learn more classification, but we separate our primates. We have ones that are wet nosed, they're more primitive, and we have ones that are dry nosed, more larger brain. This is when you think about, again, those things: gorillas, baboons, monkeys, chimpanzees. Those are dry nosed. Those are half-lorines. Okay, well, so just go through a couple of these. These stepper signs, these more primitive wet-nosed ones. This is an example. An example, not the only one, but there's others. They have large eyes and ears. You've probably seen pictures of this in movies before. These are primates, and they're the only primates. Remember, there's 200 primates. This category relies on smell for hunting and social interaction. And they're primarily found just in Madagascar, Southeast Asia, and Africa. Now, if we go to the other ones, we think about half-lorines: tarsiers, monkeys, apes. We take these, we're going to split them up into New World monkeys, Old World monkeys, and apes. Again, looking at how do we actually distinguish this? Has anyone here seen like the recent Planets of the Apes? There's actually a lot of different species, right? How do you distinguish them biologically? Well, let's do into that. We're going to start with New World monkeys. So New World monkeys are species that are found in what was classified by Europeans as the New World. Again, the Americas were not discovered by Europe until 1492. So they called them New World because to them it was a new world. They have what's called prehensile tails. It's like a fifth limb. When you think of the monkeys that can swing on their tails that you've seen in Tarzan and the Lion King, it's these New World monkeys. Next, we have Old World monkeys. These live in Asia and Africa. Their tails, they have tails. Most of them have tails, but it's not like a fifth limb, right? It just exists. And then next, we have apes. Apes have those longer arms. They have no tails. They're really flexible wrists. Apes, of course, are the most complex species. So they're social, and they have really complex vocalizations. So we're going to take these. So I just want to take a kind of step back here. So we have primates, right? We have primates, and we can split those off into these two categories. I'm going to say S and H. I can then take these half-lorines, and I can split that in 3 different ways: tarsiers, monkeys, apes. 1, 2, 3. Tarsiers, monkeys, apes. But then I can split the apes up even more. I can split up the apes into New World monkeys, Old World monkeys, and then apes again. New, old, and then apes again. And then finally, I can even go one step further. I ran out of space down low. I can then go into lesser and greater apes. Lesser and greater. So again, quite complex here as we kind of go down. So let's talk about the apes. Specifically, are lesser apes and greater apes. So lesser apes, they move through the trees. Again, you think Tarzan, right? The greater apes are the bigger ones. Those are gorillas, orangutans, chimpanzees, humans. When most people think of the primate family, this tends to be the stereotypical one that pops in their head, right? But they are only a small amount of the overall species. And then humans are in an entirely different, in a subcategory. We call them hominids, humans. Okay, so if we're looking at this kind of family tree here, So we have evolved from the ground-dwelling animals. Again, life, all life on land emerged from something that crawled out of the ocean, but then it slowly and slowly diversified. And eventually we got ground-dwelling animals that like to go up into trees to eat fruit. And eventually they managed to adapt to better survive and move around in the trees. Anyone know when the first, like how old are humans? Anyone know? We'll look into it soon. But how old are primates? Primates started about 85 million years ago. When did the dinosaurs die again? 65. So again, if we're going to the timeline to the right, here's now. Here's when we have the asteroid hit. So this is 65 million years ago. A little bit further on, we have our first primate. So yes, primates were around before. So primates were around the same time as dinosaurs, actually. So they did coexist for a little bit, not a lot. And when I say primates, I don't mean like the humans we think of. Like don't think about like, oh, gorillas were around with dinosaurs. That's not King Kong, not quite. But so we see we believe they existed around there, but we found the first fossil at 60 million years ago. So these early primates were basically lemurs, nocturnal lemurs. But slowly, we evolved. We very slowly evolved. So there's lots of lemurs 50 million years ago. They existed almost everywhere. And this is when we start to diverge. Again, you think about it. Think about that when we looked at the Earth before with the tectonic plates and like how it looked like. Somewhere during that, 200 million years ago, 150 million years ago, 100 million years ago, the continents separated, right? So now I have isolated these species. This is largely why we have different categories of apes, for example. They've evolved, we started to evolve differently. They're in different places. So we start to see these arthropods then emerge from them. And then again, we start seeing extinctions, yada, yada, yada. And basically, how come we evolved to have such big brains? It's largely believed that the ones with bigger brains just adapted better. They survived easier. And so time we got. I think we got time for one more. Okay. So that's early primates. Let's start figuring out how we emerged from this. How did humans now come from primates? So I'll head to section 2 here. Again, this is still chapter 16. So we're going to look at what hominids are. So hominids are what we call non-monkey anthropoid. We never really saw them until 25 million years ago. Again, these are precursors to humans. Large brains, free moving shoulders and hips. You can stand on one leg and you can rotate your hip around. You can do this with your arm, right? Not all animals could. So these are some features that hominids had. This is where we're going to come from eventually. So, don't need to know too much about that. That's fine. What is a hominid? Big primates, large brain size, no tail, flexible hips, shoulder joints. They have a very upright posture, right? We can walk on 2 feet for the most part. And we have distinctive molars. What does that mean? Our teeth. Does anyone know how many species of humans existed? 1 species of humans existed. 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 We've all heard of like Homo sapiens, for example, right? There have been more than one. Has anyone ever heard of the word Neanderthal? That's going to come into play probably tomorrow. But okay, so these hominids, again, so they first appeared 25 million years ago. Now, we're at a 10 million different period. There was 100 species. There's 100 of them. So quite diverse, and it originated in Africa. So if we think about it, if I have my global, here's North America, here's South America, yada, yada, Australia, Asia, Europe, Africa, sure, here's Greenland. So modern, the early hominids originated in middle southern Africa, somewhere around here, if I'm recalling correctly. And then they slowly, over time, keep in mind, over time is 10 million years, they spread out across Africa and across Asia. And at some point, they even did this. So how the heck did we get to North America again? I guess you guys weren't in that. We deal with that in another class. So how is it believed that hominids, human ancestors, came to North America and South America? At one point, here's Russia, right? Here's Alaska. At one point, this was covered in ice. So what we made what's called a land bridge, and it's believed that they migrated over. They came over here, and then they spread throughout the two continents here as well. So basically, this is the long way of saying is that over 10 million years, we started in Africa and we spread everywhere. So how does humans split off from apes? We're not talking about humans yet. We believe it's the first human, what we would consider a human, came between 85 million years ago. How do we know it's human versus a chimpanzee? We could look at something from this time period, and it's going to look more like a modern day human than a modern day chimpanzee. What's some of the difference? Chimpanzees, we're looking, their skulls are attached a little bit different. Our skulls are attached from underneath. Chimpanzee skulls are attached from the back. It doesn't seem like a lot, like a big difference, but it is a big difference. It gives us more mobility. We can look around. Also, it creates a center of gravity. This is why we are able to stand upright. You can't get these to stand upright. There's too much weight leaning forward. They're off balance immediately just from the fact that the skull comes into the back. So we know that hominids are bipedal, that they can walk upright on two legs, and again, large brains. So how come we evolved to walking two legs? What's the advantage and disadvantage of that? Most animals on Earth walk around on four legs, right? But there are ones that do navigate on two. Us, obviously apes can do it, not all the time, but they can do it. Kangaroos, again, they can lean forward, but they're largely supporting their weight with their legs. What's the advantage and disadvantage of that? So the advantages to bipedalism, 2 feet. I'm going around on 2 limbs. Takes less energy. Early life was largely about this. Stay away from predators and eat enough to not starve yourself to death. Congratulations, you have lived as an early prehistoric creature. So if you can use less energy, that's a good survival tactic, right? And not only that, you can use less energy, you can, which means you can go longer distance easier. This is a very human trait. How did humans hunt way back in the day? Think before we had tools, before we had spears, bows. We were carnivorous creatures. How did we get meat? Yeah, we could just outrun them. It's as simple as that. We could run farther than they can. So eventually you track them till they get tired and you're not. If you remember Lord of the Flies, Ralph was about to die because his legs got tired, right? Other people could chase him along. So really nice to stand on two legs because one, you're taller up, you can see better. Two, less energy. And it helps you adapt to your new environment. And it was something to do with the social structure. I never fully understood why this was an advantage, to be completely honest with you. But some disadvantages to it. You're taller, you're easier to see. You can't move as fast. You think about a bear or a crocodile or a hippo. They look like very big, fat, clumsy creatures, right? They can run like 35 miles an hour. That's like 50, 60 kilometers an hour. That's how fast they can sprint. Four-legged creatures are a lot faster than we can. They would run down Usain Bolt, the world's fastest man ever alive, in an instant. So disadvantage, right? You're not as fast. And also we have a strain on hips. It's a lot of strain on hips and backs. This is why everyone who's old has a really painful back and their hips hurt a lot, right? It's a lot of strain on. So again, these are just some of those advantages versus this. These are the same things here, So there's pros and cons too, right? It's not just, oh, you go on two legs, we're humans, we're the top of the food chain, we're the best. No, there's disadvantages and advantages. So if we look at the fossils of early hominins, remember, 5 to 8 million years ago, we start to see bipedalism as the first trait. So this is the first trait we start to see. How can I look at a fossil and identify that it walked on two legs? Any guesses what they might look for? So how can I look at a fossil and be able to, aha, this is something that walked on two legs and not four limbs? A lot of it would be how flexible the hip joints and the shoulder sockets are. That would be one possible way that they could do it. They could look at the density of the bone of the hind legs versus the upper appendages, for example, and also the length and spine. If I were to have you guys like walk around on all fours, how long do you think you could do that? If I were to like say, start here, walk on all fours, I won't have you, but it's going to be awkward, right? It's really awkward. So they're able to look at the length of your arms, your back, your sockets, and they're able to kind of reconstruct and be like, no, that's not going to work. That can't be something that they could sustain for long. Additionally, again, think about where our neck comes in. If I have you walk around on all fours, you are facing down. If I have a chimpanzee walk around on all fours, it is facing forward. So where the spine comes into the neck, like I said, doesn't seem important. It's very important. So we can look at fossils and we start to see that the skeletal structure, bipedalism, seems to be the first trait that starts to emerge in early humans. We will talk, well, no, we probably won't for the sake of time. We found a fossil that we called Lucy. If anyone here's a Beatles fans, there's a song that talks about Lucy. That's her. So this was one of the most complete fossils ever found, and it is about 3 million years old. Let me just load it up. Let me just load up a picture of Lucy. So this is Lucy. So we found this fossil. We were able to, and again, this is about 3 to 4 million years old. What did it look like? What did they look like? So we were able to look at this, and we were able to get some information. It doesn't seem like a lot, right? But if we really piece it together, they were eventually able to figure out where it enters the skull. They were able to try and figure out like the sockets and stuff like that. Look at the hips. They eventually found out that, oh, this walked on two legs. So this is just an artist's rendition. Of course, there's not a whole lot there, but this is what they believe Lucy would have looked like. Again, not what we consider a modern day human, but keep in mind, 4 years old, 4 million years old. So with Lucy, we eventually figured out a bunch of human ape-like traits, and we eventually found more. Here's Lucy. We found more and more and more and more and more, and we were eventually able to kind of chronicle how we think humans evolved, when we think the traits emerged, depending on, because we can age these fossils. We know how old these fossils are, right? So we're eventually able to, if I have a fossil that's 2 million years old that had maybe this type of hair on it, versus I have a fossil that's 1 million years old that didn't have that hair. We seem to have lost our, really great furry arms somewhere around that time. So we're able to show how these traits have evolved over time, essentially. So we keep uncovering more and more and more and more, and we keep able to sort all these different species. Keep in mind, it's been over 100. We're able to sort all of these species. So by 1 million years ago, the only hominin species we have left are homos. Does anyone know what the Latin term for humans is? Starts with homo. Homo sapien. Yes. So humans, Homo sapiens. So 1 million years ago, the only hominin left is Homo sapiens. So I really want to make this distinct. Hominins themselves are not humans. We are a very small subsection of hominins. Again, if we think about hominins, here's hominins, it branches out to a bunch of different species, right? Humans are just the one that lasted the longest and currently evolved into what we are. So we're going to end it there. We will talk more about we'll talk more about homos tomorrow. So again, what we've really done today is we've looked at the start of the Earth 4.6 billion years ago, and we've gone up until 1 million years ago. Tomorrow, we're looking at the last 1 million years. Okay. I will end it there. I know it was a lot. I apologize. We got to get it done. If you are missing any assignments, you do not have much time. You have 4 days left of learning. You will not have time in class to do it. If you're missing assignments, you have to plan out this weekend and evening something to get it done. So make sure you do that.